My name is Tom Spudich, and I'm a career academic. I work in analytical chemistry and forensic sciences. The work I do, I focus in on teaching forensic science, and I also do research in forensic science and analytical chemistry. In particular, I'm a spectroscopist by training, but I don't limit myself in that area. I've had different projects that range from using UV-vis spectroscopy to analyze different samples, to also include gas chromatography, mass spectrometry. I've worked with the Library of Congress to analyze paper for metal content. What we're doing is we're gathering data in regards to the characteristic traits of the paper to optimize conditions for treating the paper to make it last as long as possible. If you sit and think about different documents such as the Declaration of Independence or the Gutenberg Bible, the end goal is to make certain that these documents last as long as possible. So we're combining the metal content work that we're doing along with other characteristic traits that the Library of Congress has developed to optimize conditions for having the paper last as long as possible. A project that I'm particularly interested in is identifying adulterants in beverages. One adulterant that we're looking at in particular is 1,4-butanediol. That is a non-controlled substance that people are using as it's a precursor to GHB. Your body processes it and it produces GHB after processing. And so our goal is to help reduce the analysis time. Current analysis time is in multiple hours, and what we've been able to do is we've been able to analyze for it in about 15 minutes. That is important because it allows for more samples to be analyzed, and it also allows the analyst to work on other projects as needed. The instrumentation that has been most valuable to me in terms of doing different analyses include the Fourier transform infrared spectrometer with attenuated total reflectance. Also, I've needed an inductively coupled plasma optical emission spectrometer. I've also used gas chromatograph mass spectrometers, and I plan on using Raman spectroscopy in microscopy, as well as potentially Fourier transform infrared spectroscopy in microscopy. Recent advances, our analyses are faster, they're more selective, and they're more sensitive, which has been advantageous and helps reduce cost and analysis time, and has allowed me to be able to work with different samples that I wouldn't have worked with 25 years ago. So having access to the latest instrumentation allows for faster analyses, which are more selective and more sensitive overall. What excites me about the field is we've shifted a little bit to where we used to have analysis methods go as low as you can go and see as small as you can see. But we've had to adapt quite a bit to where what's good enough, because we've had to look at different things to include time, price, and space. And what we've been able to do is we've been able to optimize instrumentation and essentially narrow down what we need to answer the question. And so that's been key in terms of what we've seen moving forward. And I want to further see cost optimization with respect to different pieces of equipment or instrumentation that are available to make it faster and cheaper in the long run.